In this lecture, we are going to discuss question number 4 from question bank provided by Maharashtra State Board. So look at the question number first. We have solved the following equations by graphical method. X minus y equals to 1 and other equation we have 2x plus y equals to 8. So let us try to prepare the table for finding the coordinates of a point lie on the line. First line we have x minus y equals to 1. So let us try to evaluate here the only two coordinates lie on the line x minus y equals to 1, because given equation is the linear equation, so definitely it should represent a straight line, and 2 points together form a straight line, so that we are going to consider the only 2 points here. We have the equation of the form x minus y equals to 1. First column we have x values, then y values, and then the coordinate x comma y. Now suppose we assumed here the few values of y, and we can evaluate now the respective values of x's by using the given equation, because we have given x minus y equals to a 1. So x to be equals to, once we shift the y, we are getting y plus 1. So let us try to assume the few values of y here. Suppose I am assuming the y value becomes 2. So 2 plus 1 we have a 3. So the respective value of x we have a 3. So the coordinate we have 3 comma 2. That should be the point lie on the line x minus y equals to 1. Now once we assumed the value of y is 4, then the respective value of x becomes 4 plus 1 is 5. So the value of x is 5. So that we are having 5 comma 4 be the other point lie on the line x minus y equals to a 1. Now the same thing, try to prepare the second table for the second equation. We have 2x plus y that is equals to 8. So that we have the table for the next equation, that is 2x plus y that is equals to 8. Assume the few values of x's and try to evaluate the respective values of y, so that we have the coordinate x comma y here. So keep in mind, y to be equals to we are getting, after all shifting the 2x from LHS to RHS, that is 2x 8 minus of 2x. So once we assume the value of x is 2, let it be. So 2 2s are, we have a 4. 8 minus 4 is 4. So the value of y we have a 4. So the coordinate 2 comma 4 lie on the line 2x plus y equals to 8. Now once we assume the value of x is, let it be a 3. So that we are getting 2 3s are 6. 8 minus 6 becomes a 2. So the coordinate we have 3 comma 2. So let's have the coordinate system over here. Vertical axis is called the y-axis. Horizontal axis is called the x-axis. So that we have x and x dash, y and y dash. Both axes are perpendicular. Point of intersection is origin. You might use the scale and pencil to construct the graph of given equations. Let us try to use the graph paper for it. So towards right of origin we have all the positive integers, and towards left of origin we have all the negative integers that are equally distributed. Keep in mind, on your graph paper you have the point of intersection of dark line. Let us assume origin at that point, and towards right of origin whatever be the intersecting points of dark line, that should be the unit places. And same thing towards left of origin and the vertically upward and vertically downward. Vertically upward we have all the positive integers, while vertically downward direction we have all the negative integers like minus 1, minus 2, minus 3 and so on. Now first point we have 3 comma 2, 3 from the x-axis and 2 from the y-axis. Point of intersection we have the point 3 comma 2 and 5 comma 4. So that 5 from the x-axis and 4 from the y-axis, whose point of intersection we have 5 comma 4. Try to have now a line passing through those 2 points together. We may have, it is of the form like way. And let us try to put the equation of that line. We have x minus y that is equals to a 1. Now next line we have the 2x plus y that is equals to 8. 2 comma 4 be the first point lie on that line. so that 2 from the x-axis and 4 from the y-axis, we have point of intersection is 2, 4. And next point we have the 3, 2. Already we have 3 from the x-axis and 2 from the y-axis. Point of intersection is 3, 2. Now let us try to draw the line passing through those 2 points together. It may be of the form like way. You may use the scale and pencil, keep in mind, to draw the line. So that supposed to be we are having a line which is of the form supposed to be like that way. Let us try to have the equation of that line. We have 2x plus y, that is equals to 8. Now the point of intersection of both line, we have the 3, 2 be the point, so that we are writing at the end point of intersection of given equation, that means of given line, we have a 3, 2. So that is our solution point, we might be says. That means the value of x is 3 and the value of y is 2. Once the point lie on the line, it should satisfy both equations of line simultaneously. That means x is equal to 3 and y equals to 2 should satisfy the first equation, x minus y equals to 1, as well as 2x plus y is equals to 8 be the second equation. You may verify your answer. 3 minus 2, x value is 3, y value is 2, so 3 minus 2 is 1, we have exactly the RHS. Now x is 3, so 3 2s are we are getting 6, plus y is 2, so 6 plus 2, definitely we have the RHS as 8, so our answer is correct. X value is 3, y value is 2. Look at the second question we have, it is of the two linear equations and solve them. D to B, we have the entries under determinant are of the form 5, 7, 2 minus 3. Dy be the determinant of order 2 by 2, having the entries are of the form 5, 4, 2 minus of 10. So once we have the equations are of the form a1x plus b1y, that is equals to c1, and a2x plus b2y, that is equals to c2, then value of d, we might have the coefficients of xy from first and the second equation, that are of the form a1 b1 be the coefficients of xy from equation 1 and a2 b2 be the coefficients of xy from equation 2, so that the second row of d we have a2 b2. Now to evaluate the dx determinant, here we have to replace the coefficients of variable x from d by the constants c1 and c2. That means the value of dx we have, first column becomes c1 c2 and the second column remains as it is from d, that is b1 and b2. While the value of dy, we have to replace now the coefficients of variable y from d by we have given c1 and c2, so that we might get here the value of dy is of the form 2. We have to replace the coefficients of variable d, coefficients of variable y from d by the constant c1 and c2, while the first column from d, that means the coefficients of variable x and y remains, x and x remains as it is, that are a1 and a2. Now once we compare the given values a1 b1 a2 b2 c1 c2 with given values of d and dy, we have d of the form 5, 7, 2 minus 3 and dy of the form we have here 5, 4, 2 and minus of 10. So that coefficients of xy from first equation we have 5 and 7 be the first row of d, that are a1 and b1, coefficients of xy from equation 1 we are getting 5x plus 7y. While the constant we are having as per the dy value c1 and c2 be the constants, that are we have 4 and minus of 10 respectively. That means equation first we are having the constant as a c1 becomes a 4, while equation 2 now in it x and y coefficients we have 2 and minus of 3, that means we are getting 2x minus of 3y, that are the values of a2 and b2, and that is equals to the c2. C2 is nothing but here minus of 10. So that we have the simultaneous linear equation in two variable whose d value we have 5, 7, 2, minus 3 and dy value we have 5, 4, 2, minus 10 are of the form. I am calling them as a equation 1 and equation 2. So now we have to solve the given equations by using, let it be, we have now the Cramer's rule ultimately once we have the d and the dy value. Now to evaluate the value of d, what shall we have to do? First diagonal elements are multiplication, that means 5 into minus of 3 minus of other diagonal elements are multiplication, that means 2 into 7. So 5 3s are 15, plus minus we have a minus of 15, while minus of 7 2s are we have a 14. So minus of 15 minus of 14 we are getting minus of 29. So the value of d I am writing at last, that is equals to minus of 29. Now to evaluate the value of dx, so dx be the determinant of elements, we have to replace now coefficients of variable x from equation 1 and 2, that means 5 and 2, by the constants we have 4 and minus of 10. So that we are getting 4 minus 10, while the second column, that means the coefficients of variable y from both equation 1 and 2 remains unchanged, that means 7 and minus of 3. So 4 3s are 12, plus minus we have minus of 12, first diagonal element is multiplication, we have minus 12 minus of, in bracket I am writing now, 10 sevens are other diagonal elements are multiplication, 10 sevens are 70, minus plus becomes minus of 70. Now minus minus we have a plus, so that minus 12 plus 70 we are getting 58. So at last I am writing, therefore the value of dx we have 58. Try to make up a box to it. Now to evaluate the value of dy, already we have given the dy determinant. 5 tens are, first diagonal elements are multiplication, 5 tens are we have a 50, plus minus is minus of 50, then middle sign is strictly minus, other diagonal elements are multiplication, we have a 4 2s are 8. Now minus of 50 minus of 8 we are getting minus of 58. So that should implies now, therefore the value of we have d suffix y, that means the dy, that is equals to minus of 58. Now to evaluate the value of x as per the Cramer's rule, we have the formulation dx divided by d. Value of dx we are having 58, while value of d we have minus of 29. We well know now 29 2s are 58, plus minus we are getting minus of 2. So the value of x we are having minus of 2. Now to evaluate the value of variable y, we have the formula as per the Cramer's rule, dy divided by d. Dy value we have minus of 58, while d value we have minus of 29. Minus minus plus, 29 ones are 29, 29 twos are 58. So the value of variable y we have a 2. So the solution of given simultaneous linear equation in two variable, we have x comma y is of the form, now value of x is minus 2, value of y is 2. So that minus 2 comma 2. Now let's have a look over question number 3. For an AP means the arithmetic progression, T17 equals to 54 and T9 equals to 30. Find the first term, that is a value, and the common difference, that is d value. Keep in mind, this is the question based on the arithmetic progression as well as the simultaneous linear equation in two variable, where variables we have the first term as a and the common difference as a d. So to, as per the AP, to evaluate the nth term of an AP, we have the formula a plus, a means the first term, plus number of terms minus of 1 into the common difference d. Now we have given here T17 value, that is 54. I am writing the given data at start. Then T9 value we have a 30. So as per the formula, to evaluate the nth term in an AP, we have T17 to be equals to, now here we have n value is 17, keep in mind. So that we are getting T17 to be equals to a plus n value is 17 minus of 1 into the common difference we have a d, and this value of T17 we have given 54. So once we simplify the given equation, in terms of variable a and d, we are getting a plus 17 minus 1 is 16 times d, that is equals to 54. Let's call it as now the equation number 1. Now look at the T9 value we have given, that is 30. That means in that we have the n value is a 9. Tn, n is equals to, we have a 9 here. So let's try to replace the values. We are getting the formulation for T9 is equals to first term plus number of terms we have in 9 minus of 1 into the common difference d. This value we have given as a 30. So that is equals to, I am writing a 30. Try to simplify. We are getting a plus 9 minus 1 is 8. So 8 times d, that is equals to, we have a 30. Called it as equation number 2. Now try to simplify equation 1 and 2 simultaneously. Once here coefficient of variable a from both equation is same and having the same sign convention, that is plus and plus. So that means we have to subtract equation 2 from 1. That means we are writing equation 1 minus of equation 2. So that now we have a minus of a becomes 0 or getting cancelled. 16d minus of 8d, we are getting 8d, that is equals to 54 minus of 30, we are getting 24. Now to evaluate the value of variable d, we have to shift 8 from LHS to RHS. So that we are getting here, once 8 is the multiplier, after all shifting it will become a divisor. So 24 divided by 8, 8 3s are, we have a 24. So the d value is 3. Now to evaluate the value of a, what shall we have to do? Let us try to put d equals to 3 in any one of the equation among 1 or 2. So equation 2 is the simplest equation. We are choosing the equation 2. So from equation 2, once we replace d by its value as a 3, we are getting a plus 8 into 3, that is equals to 30. So 8 3s are, we have a 24. So a plus 24 is equal to 30. So to evaluate the value of variable a, we have to shift now 24 from LHS to RHS. 24 is the positive. After all shifting it will become a negative 24. So the value of a, we have 30 minus 24 is a 6. So the first term of an AP, that is a, we have a 6, while the common difference, that is d, we have a 3. So we can write here the AP also, whose first term is 6. So 6 plus 3 becomes a 9, be the second term. Now 9 plus 3 becomes, we have a 12, be the third term of an AP, and 12 plus 3 we have a 15, be the fourth term, and so on. So we can write here the AP of the form 6, 9, 12, 15, and so on. Now look at the question number 4. A train covered a certain distance at a uniform speed. If the train would have been 6 km per hour faster, it would have taken 4 hours less than the scheduled time. And if the train was slower by 6 km per hour, it would have taken 6 hours more than the scheduled time. Find the length of journey. Be focused on such a kind of questions. Supposed to be, we are assuming let x kilometer per hour be the speed of train, and we are assuming y hours be the required time to cover a distance, required time. So that we have the formula, that is distance to be equals to speed into time. So the required length of the journey or distance covered by us, we have distance to be equals to, now speed we have x kilometer per hour into time required, we have a y. So the distance covered, that is equals to, or the length of journey, that is equals to, we have a xy. Let's call it as now the equation number 1. Now what we have given, I am writing the condition first, is of the form if train 6 km per hour faster, then 4 hours less the scheduled time. That means now speed of a train 6 km per hour faster. That means now we are getting the speed of train becomes, originally we have the x kilometer per hour. Now faster means 6 km per hour more. That means we have to add up a 6 in x. And at the same time 4 hour less the scheduled time. Original time we have the y. So the time required to cover a journey, that is equals to we have y minus 4. So that now the distance is equal to we have speed into time, distance we have the xy, and that is equals to now we have the speed x plus y, x plus 6, and into time we have y minus 4. Try to simplify the RHS, use the distributive law. We are getting xy to be equals to, first of all try to distribute x over the bracket. We are getting x into y as a xy, plus minus minus x into 4 becomes we are writing 4x. Try to distribute now 6 over the bracket. We may have 6y plus minus minus 6 4s are we are getting a 24. So look at after xy having the same sign, opposite direction getting cancelled. Once we shift the minus 24 from RHS to LHS, we are getting 24 to be equals to minus of 4x plus 6y. Now once we divide throughout equation by minus of 2, so that we are getting the equation is of the form. Simultaneously we are interchanging RHS and LHS, so no need to change the sign of any term. So that we are getting here minus minus becomes now the plus 2x, plus minus becomes minus of 3y, that is equals to plus minus is minus of 12. Called it as equation number 1. That means we are getting here the linear equation in two variable where variables are x and y. Now look at the condition second. I am writing the condition second now. It is of the form, if train 6 km per hour slower, then we have given 6 hours more the scheduled time. So that we can say is now the speed of train is given by original speed we have the x. Now train is slower by 6 km per hour. That means we have to subtract 6 from the original speed. And the time required now we have 6 hours more. Original time we have the y. So that we have to add up 6 in it. We are getting now the distance to be equals to, already we have the total distance that is equals to the xy. Speed equals to we have x minus 6 and time required we have y plus 6. Use the distributive law over RHS. We are getting xy to be equals to, try to distribute 6 over the bracket, xy plus we have the 6x. Now distribute minus 6 over the bracket. We are getting minus of 6y plus minus minus of we are having 36. Now xy from opposite side having same sign convention getting cancelled. Once we shift the 36 from RHS to LHS, we are getting minus 36 becomes positive 36, that is equals to 6x minus of we have 6y. Now look at the coefficients of variable x, y and the constants, all are divisible by 6. So try to divide throughout equation by 6. We are getting the equation is of the form, after all interchanging the LHS and RHS, 6 ones are we have a 6, so x minus of 6 ones are we have a 6, so that y, that is equals to 6 6 are we have a 36, so that we are getting a 6. Now look at the equation number 1. We have it is of the form 2x minus 3y equals to the minus 12. So try to multiply the equation whatever we are getting at the last by 2. So let us try to multiply equation by 2. So that we are getting 2 into x is 2x minus 2 into y is 2y, that is equals to 6 2s are 12. Call it as now the equation number 2. Look at the equation 1 and 2 carefully. Is in the equation 1 and 2 coefficient of variable x is same, 2 and 2 having the same sign convention, plus and plus. So try to subtract now equation 1 from 2. So we are doing equation 2 minus of equation 1. So that should implies 2x minus 2x gives us 0 or getting cancelled. Minus 2y plus 3y, minus minus becomes plus because we are subtracting here. So minus 2y minus minus plus 3y we are getting a y, that is equals to 12 minus of minus 12, minus minus becomes plus 12. So 12 plus 12 we have a 24. So that we have now y value is 24. That means time required we have the 24. Try to evaluate the original speed of train so that we are getting the distance is of the form speed into time. So to evaluate the value of x, we have from equation number, let us we are taking 2, is of the form 2x minus 2y, that is equals to 12. So that should implies 2x minus of 2 into y value we have a 24, that is equals to a 12. 24 twos are we have a 48, so 2x minus of 48, that is equals to we are getting a 12. Shift that 48 from LHS to RHS, 2x to be equals to we have 12 plus 48, we are getting a 60. Now to evaluate the value of variable x, shift the 2 from LHS to RHS. 2 is a multiplier, after all shifting it will become a divisor. Divisor to who? To 60. 60 divided by 2, we are getting a 30. So the speed of train is 30 km per hour. So at the end we are writing the original speed of train, that is we are having 30 km per hour, and the time to complete the journey is equals to 24 hours. So to evaluate the distance, that means the length of journey, we are writing length of journey, that is equals to, now we are having speed into, that means the distance, we have a speed into time, that is originally we have the speed is x and the time is y, so x into y. So the value of x we have a 30, value of y we have a 24. 30 into 24 we are getting 720, unit we have the kilometer. So length of the journey we have a 720 kilometer. Now let's have a look. Question number 5, solve 0.4 times x plus 0.3 into y, that is equals to 1.7. 0.7x minus 0.2y, that is equals to 0.8. So let's try to assume that first equation we are having 0.4x plus 0.3y, that is equals to 1.7. Here the coefficients of variable x and y as well as the constants are all in terms of the decimal numbers. So try to convert them in terms of integer as a coefficient so that we can solve the simultaneous linear equation in two variable easily. So once there is a after one place we have the decimal in case of coefficients of x and y from LHS, and after one place we have the decimal in case of the RHS, that is the constant. So try to multiply both side by, we can say 10, because since there is a decimal after one place, that's why to cancel out the decimal we are multiplying both sides by 10, so that we are getting here 0.4 into 10 is 4.0, means a 4, x as it is, plus 0.3 into 10 we have a 3.0, that means a 3 times y, that is equals to 1.7 into 10, we are getting 17.0, means a 17. Now called it as equation number 1. Second equation is of the form 0.7x plus 0.7x minus 0.2y, that is equals to 0.8. Again we have after one place the decimal point in case of coefficients of x and y from LHS, and same thing after one place we have the decimal in case of RHS, that is the constant. So try to multiply both side by again 10 to convert the decimal as a coefficient and the constant in terms of the integer value. 0.7 into 10 we are getting 7.0, means the 7, x as it is, minus of 0.2 into 10 we have 2.0, means a 2, y as it is, that is equals to 0.8 into 10 we have the 8.0, means the 8. Called it as now the equation number 2. Now let's have a look over the coefficients of variable y. In case of equation 1 we have a 3, in case of equation 2 we have a minus 2. Once they are having unlike sign conventions, so we decided to eliminate y variable here. So for that we have to make firstly the coefficients of variable y from equation 1 and 2 should be the identical or the same. So 3 and 2 having the LCM as a 6. We are having 3 2s are 6. So that's why we are multiplying equation 1 by 2. And simultaneously, in case of equation 2, we have the coefficient of variable y is minus 2. So 2 3s are we have a 6. So that equation 2 should be multiplied with the 3. So the new equations are of the form. After all multiplying equation 1 by 2, we are getting. So each and every term should be multiplied with the 2 now. 4 2s are we have a 8 x as it is. 3 2s are we have a 6 y as it is. That is equals to 17 2s are we have a 34. Called it as equation number 3. Now equation 2 should multiplied with the 3. So each and every term of the equation 2 should be multiplied with the 3. 7 3s are we have a 21 x as it is. 2 3s are we have a 6. So minus of 6y. That is equals to 8 3s are we have a 24. Called it as equation number 4. Now look at the equation 3 and 4 carefully. Once we add up the equation so that we can eliminate the value of variable y. So that now equation 3 plus equation 4. Once they are having the unlike sign convention, that means the coefficients of variable y are having the unlike sign convention. So that's why we have to add up them. 8x plus 21x, we are getting 29x. 6y minus 6y gives us 0y means the 0 or getting cancelled. That is equals to we have 34 plus 24, we are getting 58. To find the value of variable x, shift at 29, we are getting 58 divided by 29. That will be the 2. So the value of x is 2. Now to evaluate the value of variable y, let us try to put x is equals to 2 in any one of the equation, either 1 or 2 or 3 or 4. Among them, we are choosing the equation 1. So I am writing now from equation 1. Equation 1 is of the form 4x plus 3y, that is equals to 17. Try to replace x by 2 so that we are getting 4 into 2 plus 3y, that is equals to 17. 4 2s are we have a 8 plus 3y, that is equals to we have a 17. Now shift the 8 first from LHS to RHS so that value of 3y, we are getting 17 minus 8 is 9. To evaluate now the value of variable y, shift that 3 is a multiplier. After all shifting, it will becomes a divisor to 9. 3 3s are we have a 9. So 9 divided by 3, we are getting a 3. So the value of variable y is 3. So once we simplify the given simultaneous linear equations in two variable, we are getting the value of x comma y to be equals to x is we have a 2 and y is 3. So x comma y equals to 2 comma 3. Now look at the question number 6. Last question we have from the question number 4. It is of the form. The semi-perimeter of a rectangular shaped garden is 36 meter and the length of the garden is 4 meter more than its breadth. Find the length and breadth of the garden. So look at the shape of the garden. We have the rectangular shape. So let's have firstly the rectangle. Assume that it is a garden whose length we have a L, breadth we have a B. So what is mean by the perimeter at start? Perimeter is nothing but length of sum of length of all sides. That means we have the perimeter to be equals to L plus B plus L plus B, because pair of opposite sides of the rectangle are equal and parallel. That means once we add up them, we are getting 2 times L plus 2 times B once we take 2 common, so that we are having 2 times length plus breadth be the perimeter of rectangle. We have given here the semi-perimeter. What is mean by the semi-perimeter? That means perimeter divided by 2, we have the semi-perimeter, ultimately half of the perimeter. So half times we have the perimeter is nothing but 2 times length plus breadth. 2 getting cancelled, so that the semi-perimeter becomes just a length plus breadth of the rectangle. That means we are having L plus B. So let us assume that now length of the rectangle to be equals to, we have dimensions are in terms of the meter, so we are taking L meter, and simultaneously the breadth of the rectangle we have, let it be the B meter, so that the semi perimeter of the rectangle is L plus B. So L plus B equals to the semi perimeter we have given the 36 meter. Called it as now the equation number 1. Look at the second condition. What we have given, length of the garden, that means the L is 4 more means we have to add up a 4 in the breadth. So as compared to the breadth. So once we shift the B from LHS to RHS, we are getting L minus B equals to a 4. Called it as now the equation number 2. Look at the equation 1 and 2. Once the coefficient of variable B is 1 in case of equation 1 and minus 1 in case of equation 2. Once they are having the same coefficient as a 1 and 1 but having the opposite sign plus and minus, so that we have to add up the equation 1 and 2 to eliminate the variable B from equation 1 and 2. So what will happen once we add up the equation 1 and 2? L plus L we are having 2L. B minus B, that means 1 minus 1 is 0, 0 times B is 0, that means here B getting cancelled. That is equals to we have 36 plus 4 is 40. To find the length of the rectangular garden, we have to shift 2 from LHS to RHS. 2 is the multiplier, after all shifting it will become a divisor to 40. 40 divided by 2 we have a 20. So the length of the rectangular garden is 20 meter. Now to evaluate the breadth of the garden, let us try to put the L value as a 20 in case of any one of the equation among 1 and 2. We are choosing the equation number 1, so that I am writing from equation 1. Equation 1 is of the form we have L plus B, that is equals to a 36. Value of L is 20. Try to put L equals to 20, so that we are having now 20 plus B, that is equals to the 36. To evaluate the value of variable B, try to shift 20 from LHS to RHS. Plus 20 becomes minus 20. Now 36 minus 20, we are getting a 60. So the breadth of rectangular garden equals to 16 unit is meter. So that at last I am writing length of garden is equal to, we have a 20 meter, while breadth of garden is equal to, we have a 16 meter. Now today we will stop here. During the next lecture we are going to discuss question number 5 from first chapter, that is the linear equation in two variable, given in case of our question bank provided by Maharashtra State Board.